Today, I'm still going to continue with the introduction to the basic components used in our industrial installation. And one of them that I'm going to discuss today is magnetic contactor. Magnetic contactor. A magnetic contactor is an electromagnetic material that is used in our industrial installation to handle our load. It comprises of two contacts. Two contacts. One is movable and the other one is fixed contacts. Example, this is the movable contact of the contactor. Have you seen it? And this is the fixed contact. These contacts here, 1, 2, 3, and 1, 2, 3 here, they are the fixed contacts. Whenever this movable contact moves, it creates a link between the upper terminals and the lower terminals of the fixed contact, which means when the movable contact is not moved, the upper terminal in the fixed contact and the lower terminal in the fixed contact, they are open. There is no continuity between them. But anytime the movable contact moves, it moves down in order to create a link between the upper and the lower terminal. The magnetic contactor at the same time has what we call energizing coil. Energizing coil. It is the energizing coil here that drives this movable contact. If I put live and neutral supply at this energizing coil here, there is a coil in there. That coil is suspended on a soft iron core. The moment you supply live and neutral here, the coil carries current and the soft iron core in there becomes magnets. When the soft iron core becomes a magnet, it is going to attract the soft iron core on the movable contact. So the movable contact moves and closes. If you look at this space here, you can see when it moves like this, it will close. And when it closes, it creates a link between the upper terminals and the lower terminals of the fixed contact. So if I put a supply here, let's say line 1, line 2, line 3, this line 1, line 2, line 3 is going to have a continuity with the lower terminals. Assuming I have the supply here and I have electric motor here. Once this movable contact moves, it creates a connection between the terminals of the electric motor and the supply that are here. And when you look at it, let me quickly demonstrate that for us. In this magnetic contactor here, you can see the coil that I showed you. These coils are normally labeled A1 and A2. A1, A2. Anytime you see a magnetic contactor and you see A1, A2, they are telling you that is where you are going to put the supply to energize the coil of the contactor. So the coil is of lower rating. The coil is of lower rating. So anytime you put the supply at A1 and A2, live and neutral, depending on the voltage, you need to check your contactor to know the operating voltage for the coil before you connect your coil. So when you connect it, the soft iron core on which the coil is suspended becomes a magnet. And you know, a magnet will attract a magnetic material. So this is built on a magnetic material. It will attract this, and this goes down and create the contact between them. So let's see. Let me test it for you and see. Have you seen it? Have you seen it? So once the current gets to the coil through the A1 and A2, the movable contact, which is built over another soft iron core, is attracted by the soft iron core of the fixed contact. So when they become attracted, the attraction will cause a link between this contact at the upper part and the contact at the lower part in the fixed contact. So whatever supply you put here, there is going to be a continuity for them at the other side. So in this case now, there is a continuity between this terminal here and this terminal here. There is a continuity between this, and there is a continuity between this and this. And the moment I switch it off, there is now continuity again between this set of terminals here and this set of terminals here. Hope that is clearly understood. For you to understand it better, let me explain this to you on the book and see how it works. Now, internally, our magnetic contactor is designed this way. This is the coil I'm talking about, the energizing coil of the contactor. This energizing coil is wound over a soft iron core, which is the one at the base here. So then the movable contact that I talk about, this is it. And look at it here. This is the setup. This is the movable contacts. So anytime you apply the supply at A1 and A2, let's say A1 is neutral and A2 is live. What happens is that the soft iron core here, over which the coil is suspended, will become a magnet through the process called electromagnetism. And when it becomes a magnet, it is going to attract this movable contact, because the movable contact is also built on another soft iron core. So the separation between them, there is a spring here. There is a spring here. So once this one becomes a magnet, it will attract this. And once it attracts this, the movement towards this will cause this contact here and here to close. And this one will become consequently close to this one closest to this, and this one closest to this. And the moment you remove the supply from A1 and A2, this soft iron core here loses its magnetism, and this one returns to its initial position. It is pushed backward by the spring that is sandwiched between the two. And this continue on and on and on. Anytime you either put a supply here or you interrupt the supply. You know how to control your contactor. All you need to do is to find different devices such as switches, such as relay, such as sensors, and so on, to control the supply to the coil so that your contactor can be open or closed at any time. For example, if I want to use this contactor now to drive a motor, and that motor, I want it to operate only when there is an object at a particular point. So which means I'm going to use a sensor which will sense the movement of people. And once the sensor senses the movement of people, it will send that voltage. It will close and send the voltage to the coil closes, and the motor operates. Once there is nobody there again, the sensor retracts the voltage, and the coil opens, and motor consequently stops. So that is how the magnetic contactor works.